morning, everyone. Thank you so much, Jordi and Santi, for inviting me, and the Data Council as well. Pleasure to be here with you this morning. Like Jordi mentioned, most of my time, I work for, I think, 5 years at Microsoft. Most of my time I spend with our customers, mostly large enterprises in different verticals. My background is mostly computer science, then I moved to the data space. I've been doing cloud computing, as you can see, for more than 10 years. And I really like to sit with companies, customers, helping them to solve business problems, mostly for data science perspective, on top of cloud. Of course, on Microsoft Cloud, Azure. And today I just wanted to share a little bit different experiences and technical tips or practices that I've seen different companies adopting to make their data science processes and teams a bit more agile, or helping them to deliver best business value or more agility, especially as you grow in your data science practice, to make it more effective and also possible at scale. That's a little bit the idea. I must tell you there's a few things in my presentation that you might don't agree, you might be shocked. That's great. I invite you to drop me an email or connect with me on LinkedIn, and as Georgie mentioned in the end, there's also some time that you can make any questions and discuss different perspectives. But those are just a few things that I wanted to highlight. So the first thing I see in organizations, once more large organizations, large companies, is that the last few years, of course, machine learning is not something new. I think it's just becoming more popular, more adopted for different facts. I think cloud computing is one of them. Open source is another one. People more skilled on that space as well. But I see there's a big trend on the data science teams, because initially data mining might have been with statisticians, a very individual job. So people were doing a few statistical models, predictive models on their laptop and connected, of course, with the business. But more and more, I really see in the conversations with the teams I have, from chief data officer, head of analytics, data science teams and business teams, that is really a shared sport, okay? And by that, that means that there is also a change in process that needs to be in place, okay? First thing I think coming from top is that, of course, companies need to have a data strategy. Of course, I will not bother you with that topic, but that's extremely important. Then over time, of course, when you have data, more data needed for your business, drive a, let's say, a culture of data-driven decisions. That's definitely what teams want to do. And then there's a few roles that play in this discussion. This slide is just a subset of that. Today we're going to focus, most of my practical tips I want to give you are, of course, going to be focused on data scientists. But of course, as you know, there was just talk before, and as you know, there's a different track on data engineering. That's a big part of the job before you can start to get and work with the data. I forgot to when I introduced myself, to ask a few questions to you, so I know better who's in your team. Who's the data scientist, by the way? Okay, that's close to 50%. That's great. Data engineer? Okay, some people skip the other track. Managers? Okay. And who works for a startup? Who works for a large enterprise organizations? I feel like 50% on all my questions. Okay, that's great. So like I said, there's a lot of processes that need to be in place. In the end of my presentation, I have a link to one of the options to adopt a process for data science from end to end, because it's not just about one use case, it's about getting the business with new processes and adopting them. So from now on, without going into detail with all the roles you see in these slides, is really about what I think you can do practically to improve your data science practices. Just 5 tips. Hopefully they will fit in half an hour, and there is some demos in the middle. First one, of course, data science is an extremely interactive job, right? You start with the business problem, you get some data, you start to build models with your favorite programming language, your favorite frameworks, sometimes using more sophisticated methods as deep learning, but you don't need to. Then, of course, most of the time is really about tuning your models, the parameters, do more experimentation, create our machine learning pipelines. And then, of course, that doesn't finish. That's why I had a slide before about teams. When you have a predictive model, you need to have a process to deploy that into production and get it integrated with your applications and end users. Okay. So one of the things I've seen that I think it's very important, especially when it's not one person, it's 5, 10 people doing data science in a company, sometimes across different departments. Some people might be doing pure code, some people might be doing more visual things. Is really about every time you run machine learning experiments, or every time you do some different, trying a new algorithm, trying a new parameters, make sure that those experiments are tracked, okay? Because first you have a record of everything that is happening in your data science practice, especially when you have a team, when you're doing different projects, that's really important. And second, because you want to find what is better over time. And sometimes you don't remember exactly how did you achieve that. I've seen people doing that. So that's also for reproducibility. So some point in time, you want to know how did you achieve some result with which parameters. Let me show you a very simple example what it means, of course, using the cloud. In this case, it's interesting because I'm still using my laptop. As you can see, this is Jupyter on my laptop, so I'm still running locally. The only thing I'm doing is importing a small SDK, Python SDK in this case. Just checking the version, connecting to my workspace. That's a service that we leverage in Azure for Azure Machine Learning. Those are just some details behind the scenes that are not relevant. Sorry, there was this one actually. Those are just the configuration parts. Then what I'm doing is I'm running an experiment. Sorry, this is really the right one. Okay, we start with this one for sure. Okay, now it's the right place. Okay, so I'm saying I'm doing a training. I'm just experiment name and locally. This is my train file. Not going to bother with the details. This is standard for data scientists data set from scikit-learn. This is just my training file. I have just an auxiliary library. Then I'm saying I want to use my laptop environment. So in this case, of course, Conda to have easier life. Then I'm just saying that I want to submit this to my environment. Once more, this is my laptop. I don't need to get out of it. I will be running my experiment. With a few seconds. Of course, it's a simple model. And now, I can even see how it iterates over time. As you can see, this is really fast because it's a simple problem. I'm iterating over time. My alpha and MSE are changing. Okay, this is nice. I already see what is happening here, but back to my original idea. The idea is that you have a place where you can centralize all your experiments that you have run. So what I'm doing now is swapping to a graphical view on Azure. That basically, all the runs I've run in my laptop right now, I have a graphical way to see over time everything that happened behind the scenes. Okay, in this case, I did just a few iterations, but I can already see what are the key metrics I want to track, and over time, how they perform. Once more, this is a very small example. Then I'm going to run something a bit more complicated, but that's already a best practice. Secondly, let me find the right notebook this time at the beginning. Secondly, I'm doing exactly the same thing, but of course we said that we want to leverage the cloud and still keep the principle of tracking experiments. What I'm doing now is running the same experiment, but saying I want to have some extra power. Of course, my laptop has a limit of CPUs, of course, and memory. I want something bigger. I want a bigger virtual machine in the cloud. So I'm creating a new experiment that I call it train on remote VM, passing all the parameters, getting the data sets. I want to bother with the details. Once more, I have a file with my training script, very similar to the previous ones. Then I'm attaching it to the machine, running it. I've run it this morning, so I can save some minutes during my presentation. As you can see, these are all the details of alpha, MSE, and all my Conda packages within the environment. When it's finished, we can go back to the portal. Not yet that one. And now in this case, as you can see, this one took, I think, 5 seconds per iteration. Our credentials have expired. This is what happens when you change IPs. Give it a second. Okay, as you can see, now I see for every run in my code, of course I'm swapping parameters, how long it take, and what was the values I'm tracking for MSE. So I can very easily come here and see which one I had the lower MSE. Okay. So this was my first tip. As you can see, using Azure Machine Learning or potentially other ways, you have a centralized place where you just log your code, no matter where you're running on your laptop, in a bigger virtual machine with CPUs, GPUs, you just are able to track what you're doing and what your team is doing. Okay, so that's one first tip I will start with. Second one I think is extremely useful, even for professional data scientists, which might be more than 50% of this room, is to leverage what we already have out of the box in the cloud. So there is this concept of cognitive computing, which is basically the idea is to build APIs, pre-trained models that are consumed as RESTful APIs, where we embed some of the capabilities of humans. That's what it's called cognitive, right? So you have vision capabilities, speaking capabilities, understanding capabilities. What you see here is just a very small subset of what is available as a cognitive service, as we call them in Azure Cloud. But basically, the idea you have a model that has been trained. Most of them are deep neural networks, trained with a very large data set to solve one or multiple problems, and you can just consume them. Why I'm mentioning this to professional data scientists? Because sometimes when you're starting a small project or a small problem that you want to fix, sometimes it's not worth the time or the investment to train your full model from scratch, because you just want to validate that you can achieve something, or you don't have enough data to train that model. So one way is maybe start with those APIs. More and more over time, those APIs start to be more customizable. So you can basically modify the external layers of the neural network. Okay. So one example of a cognitive service is for forms. So you have a set of forms like a medical checkup, tax declaration, or any kind of document actually. And basically, using one of those cognitive services, I know it's a video, basically just sending the document, the PDF there, it just scans, it detects tables. This case is an invoice, could be also a receipt of a bill, and basically just tries to figure out what's the information there and extract it as a JSON. So you know exactly what is a table there, what fields, and so on. That becomes unstructured into structure. Okay. Once more, think about doing all this from scratch in the data science project. Two more things I wanted to show you where you can leverage cognitive computing. So these are the 5 categories I mentioned. Vision is one of them. So a few things that you can do with this service is, for example, analyze an image. Okay. In this case, I'm sending a picture of a scene. It's detecting people. It's detecting there is a subway and a train. So I said, okay, why don't we try with a different thing? Okay. So I went to my browser and I saw there is some nice picture of the day of penguins. So I took a screenshot of that picture and see how it performs there. This is the right one. Okay, same picture I showed you. Sending it to the cognitive service. So it's able to identify a lot more things that I mentioned to you. It can also identify people, if their emotions, their gender, their age, their position of the body. There's a lot more things it can detect. But in this case, I'm just sending one picture I just found this morning in my laptop, if the connection stays with me. Okay, as you can see, it detected actually penguins. So it's actually trained to identify some objects. And not just the penguins, of course, you have the bounding boxes of that, and you have a few keywords: animal, outdoor, snow, group, bird, and so on. So that's actually pretty good. Second example I wanted to show you is, I think, a pretty complicated data science problem, which is detect handwritten text. Okay, I've actually been in a few projects with companies, with data scientists to write them from scratch, and they are not easy to tackle. So this morning I just wrote this. With my handwritten, which is not the most nice looking one, but it's mine. So what I'm doing is I'm just sending this to this API and saying this is handwritten. And as you can see, even though I don't have the most nice looking handwritten, it detects exactly what I've wrote. It's more, the result is a JSON. You can even find the location of each word with the bounding box and so on. So those were just a few examples. There is a lot more of cognitive services I wanted to show you, because once more, sometimes it's not worth to start from building your models from scratch. Just leverage things that are pre-trained and combine them with your own train and build them into your data science pipeline. Same thing for text analytics. There's a couple of good ones, translation, and so on. Okay. Next one I want to mention to you is, even though you might be very professional data scientist, you love code, I love code personally, sometimes it's worth to don't start always with code. And for that, I'm referring when you have a small business coming to you with a small project, you just want to validate, they just give you some data and you want to see if that probably is feasible or not with a data science approach. Sometimes it's easy to look at graphical interfaces. So what I'm going to show you to you is a possibility, if my screen allows me. Okay, interesting. I have one screen there and a different one here. Let's see if I can fix that. Okay, out of full screen, we are back. So one idea here will be to use a graphical interface to quickly mock up a data science process. It is also very effective for non-professional data scientists, typically citizen data scientists, business data scientists, someone who really understands the business, has understanding of a machine learning problem. So there's a graphical interface to do that. Basically, as you can see, you just start to drag and drop boxes. This one actually is already pretty done. I wanted to show you from scratch, but we are short on time. So basically, I'm importing a data set. In this case, I have some sample data, just imported here. I connect it to a split data to split my training and test data set. I'm picking one of the many available algorithms there. As you can see, there is for classification, clustering, and regression. I just pick one of them. Of course, I can fine-tune some of the parameters. Then I'm scoring it. I'm getting the result. I'm getting the test set and evaluating the model. Okay. To prove to you that this works, let me just go to the experiment that has been run already. There it is. When you run, basically, you specify what kind of compute you want to have behind the scenes, depending on how complex is the problem. And once it's there, basically, you can come here and see. First, look at the data set. It's actually quite useful. Once more, you get a business data set. Just want to look at it with some statistics. You get it out of the box, and you run your model. And then, in this case, I just want to visualize the results of the scoring with my score labels. Another very interesting thing here that you can do after testing your, after training your model, you can click on deploy web service, and literally with a few clicks, I won't be doing it now because I've done it before, you're going to deploy your model as a predictive web service. Okay, let me show you that. I've done that just before to save some time. So I have endpoints, it means it was deployed from that studio I showed you before. This one. And as you can see, there is a scoring URI which I can connect to and make predictions. If I actually go back here, sorry, if I go back to web services, that's exactly what I wanted to show you before. Sorry, connection is not helping me, so bear with me. Okay, this is my deployed model I've shown you before. It's basically to predict the value of a car based on a set of inputs like the age of the car, how many kilometers, what was the initial price. So this is the deployed web service. It's deployed as a container because that's the industry trend these days. So this is the variables I'm sending to the predictive model, and now I'm just sending those ones, connecting to the endpoint and getting a result back. And the result of the prediction in this case is the value of the car. Okay. It gives you also out of the box some code samples to connect by yourself, or if you really want to connect at low level, it has also the RESTful API specification. So you have seen within just in this case very little minutes because we don't have much time, but how can you leverage a graphical interface to build predictive models? I forgot to mention that you can also bring your own code, so R and Python can be in the middle of your flow there, so you can still code, and basically how to deploy that as a model. So I think it's a very valid way to prototype quickly and sometimes even to take your experiments further and faster. Okay. Next tip I wanted to show you is about leveraging automated machine learning. Anyone using it on your day-to-day practice already? One person. Okay, that's a good sign. So automated machine learning basically tries to make your life as a data scientist a little bit easier. As you know, when you start doing a predictive model, there's a lot of time behind the scenes of trying different algorithms, different parameters, and fine-tune them. That can be really, really time-consuming. let me skip a few animations and show you how it works in our graphical interface. The idea behind the scenes is, of course, as a data scientist, of course, you know better than anyone how to build models, the best models, but it can kind of automate part of your process, basically testing a lot of different algorithms, test them in parallel, and fine-tune all the parameters, which I think can save you a lot of time. And by the end of the day, after you've run this kind of experiments, you can still retrieve the model and see what are the variables that are more impactful, and based on that, still keep carrying on your job. I think the connection is not really helping me a lot. I prefer to show you the real thing than just the animation. Let's give it a try, otherwise I have an animation I can show you as well. Okay. So basically, I've run it before to save some time. Basically, I provision a dataset, which I'll show you in a second. Okay, now I'm just specifying the name of the experiment and what is the compute behind the scenes. I'm loading the dataset. This case is a banking dataset, a public one, what basically is about trying to detect if a specific loan or offer I want to make to the customer, you will take it or not. You can see here the variables, age, job, a lot of them. I can very easily say, for example, don't include, I don't know, day of the week might not be included. Okay, you can look at the profile of the data per variable. And then, where the automated machine learning happens is here. Basically, I'm saying what metric I want to track on. In this case, I'll take AUC, weighted. How long I want this to be running, because it can be running for a lot of time, and also, of course, the cost of its running is impacted to you, or the max of interactions you want there. What kind of validation you want to make, number of cross validations, the concurrency, which is interesting. You can start to parallelize things and save some time. And basically, a lot of algorithms that you want to try, or if there's something that you specifically don't want to test it, you basically say, I don't want to use those two SVM and linear SVM. Okay. After that, it submits. It, of course, needs a few minutes to get started. And once it's run, as you can see, these are iterations over time, and this is the metric I'm tracking, AUC. So I can see here, for each algorithm, first how long it took to train on which of them, and then in this case I want to see which one performed better, which was the voting ensemble, which was actually I think the last one there on top right. Okay, very interesting to automate part of your machine learning processes. Okay, so my last tip might be the one that might be a bit more outside of what you've seen on data science practice. If not, I'll be very happy. Which is really about helping you to build kind of, if you want to call it a machine learning factory, basically being able to chip more machine learning models into production, make sure that they are tracked and that you can detect that they are decaying performance over time, and you can automatically retrain them. That's kind of the idea. Of course, for that, it requires, I think, a big change in processes and, of course, the tools behind them. The idea is to embrace the concept of DevOps. Everyone talks about DevOps these days, really about be iterative, experiment fast, experiment quick, fail fast, and have a complete feedback loop. That's the idea with general software development. Reality is in machine learning world, it's slightly more complicated than deploying a web application because of the data and the models and the performance, and that we know that over time models will decay accuracy when they are deployed. Okay, so there's a few things that I think are important if you want to embrace this concept of machine learning operations, which is basically, of course, reproducibility. That's why I started with the experimenting. Then validation, of course, automation machine learning might help you there, but that's an optional step. Then of course, how do I deploy models and how do I retrain them? So from a very generic point of view, the idea is you have data scientists, like most of you guys, training your models. You should be able to have a central place where you have what we call a continuous integration, continuous deployment pipeline, which means that your code is basically every time you change your code or you make a commit, you say, behind the scenes, I want to automatically, for example, run some tests on my model and deploy my model into pre-production or test environments. I think it's really interesting because, of course, it brings extra engineering skills to data scientists, but also give you the capability to really deploy your models, test them, and potentially, if you have some applications or even dashboards that you want to connect to your predictive models and see how it looks like and show it to the business, I think it's really a good way. So that's the main idea. Secondly, over time, the models will decay in performance. So the idea is that we collect the metrics of the models, we centralize them in some place, and basically we are able to retrain the model, hopefully to improve it. Or if it doesn't improve, at least I should be able to detect that and in extreme cases, take it out of production. Okay. Without going further, I'll just show you a small demo. There's some slides about each and every steps, but let me just show you a demo. In this case, we use a specific tool for DevOps with the idea to use for machine learning processes. So here I have a very simple pipeline that I've defined before, machine learning pipeline for continuous integration. Let me show you how it looks like. So what I'm doing here is defining a few steps. One of them is I'm just saying I want to use Python. And then the most relevant one for data science is I have a few scripts in Python, as you can see, which is one is training. That's very similar to what I showed in the beginning. Then I have another script to say I want to evaluate my model. Once my model is evaluated, I will register that with a central register for models, so I can track all my models into production, and then generate a container to potentially deploy that. Okay, I've run that before, and basically takes, in this case, I think 3 or 4 minutes. Let's pick a successful one. Remember, this is every time I save my code or I commit something, this happens behind the scenes. So it doesn't affect my job as data scientist, but as you can see, for every step, starting, let's say, maybe with start training on local. Local is some machine, remotely in this case. Then, well, before it was installing packages. Then I'm running evaluate the model, just takes 10 seconds. Registering the model. And in this case, the interesting part maybe for you here is this line. It says that the model I have currently in production has this amount of MSE, and the new one has that one. So based on that, it has some logic to say, do I take it into production or do I just keep it? Okay. And finally, when the build, because this was just automated build of your code, is done, I might have a way to release that into production. In this case, I've deployed this as a single container. Behind the scenes, it took, I think, 5 minutes. So once more, is an API exposed. I can consume it. And if I want to take it into production, I could make a trigger. And of course, production, things are very sensitive, so it might need a human to go there and approve that. That's kind of the idea. Okay, just one last minute. I know we went a bit quick on a lot of different concepts, but basically the idea is that as Microsoft, we've been doing, of course, machine learning for more than 25 years. We've been investing very hard and a lot on bringing artificial intelligence and sophisticated machine learning tools for any kind of profile, from professional data scientists, citizen data scientists, application developers who want just to build some AI. That's the capabilities of our platform. My experience, like I told, with big companies, and you see names of big companies and the business impact they had with adopting some of these processes and tools, I think it can be very big, especially when you think about scale from data science perspective, but also scale from industrialization of your machine learning models. My closing thoughts, and you're going to have access to the slides, 2 things. One of them is read about the data science project. It's really similar to CRISP DM, but I think more modern. If you want to try Azure Machine Learning, I think it's extremely interesting because of some of the features. And today we didn't go very deep, but there's a lot of other concepts that I think are worth to make your data science process even better. Particularly one of them is detecting data drift, manually or automatically when you have models into production. A big question I get very often from customers is how do you interpret the models behind the scenes? So there's also capability to have model interpretability, and of course leverage the hardware. GPUs, FPGAs are really cost performance efficient when you have complex workloads such as deep learning. Okay, and with that, I think we are on top of the time. I appreciate your time. Feel free to ask any questions now or later, or reach out to me. Thank you.
Thank you for your speech. How is your system, your UI interface, how it is suitable for using deep learning models such as based on TensorFlow framework?
Sure.
Is it possible to load some pre-trained models from meta files or something like that? Thank you.
Yeah, good question. Thank you. I didn't go too much into that detail. Today, the system you've seen, which is on Azure, it's really tries to be a non-opinionated system, which means that we just want to let you leverage your favorite tools. By that I mean you can use any open source framework, including PyTorch, TensorFlow, or any of them. So you still control completely your code, the frameworks you want to run. So it's completely compatible with that. On top of that, optionally, like you've seen, I was running a very simple training in a big VM. I could be running the same training in a GPU VM to, of course, to improve my time. So the answer, yeah, bring in any framework, and you have infrastructure like GPUs on demand, which is very interesting. You just use it for a few hours and you spin it down, which is a big cost-effective.
I noticed that when you are running this, it keeps you constantly complain there's no internet, which slows down your process.
Yes.
So is it true that this Microsoft Azure will heavily depend on internet connection? So there's only one version, which is cloud version, right?
Yeah. So I think we need to have better internet connection for sure. When I test this at home or in my laptop in the office this morning, it works perfectly. So I think it's just if you have low latency, of course you experiment that. But you're right, that's accessible through the public internet. Of course, that's the main idea with cloud computing in general, not Azure not just the machine learning capabilities. I showed you the example where you can start on your laptop, but to get all these capabilities, doing automated machine learning, CR experiments, leverage GPUs, of course, you need to have some connection to get to the endpoint. But that's just what you should expect to get in your work normally.
Yeah. Another question is a bit challenging. Hope you can handle it. So, for example, our company have already two kind of softwares, or what is offered at Global Deal. One is Cloudera, data science workbench.
Sure.
So it's completely based on Jupyter Notebook or R or Scala, and also supported by the big data infrastructure. Another is a Wrapup miner. So basically one version for non-coding people, another version for hardcore data scientists. So the thing is that every company have their own deal. What is your competitive advantage comparing to Cloudera or Wrapup miner?
So firstly, Cloudera is a big partner of Microsoft for a long time, and there's customers who are running Cloudera large clusters on top of Azure. So I will not say it's just either one or the other one. I think if you are existing Cloudera investments with happy practice, you're happy to leverage that in the cloud. The good fact is that you will be able to scale up your cluster or shut it down. That's already a big advantage. Second thing I would say is we've been, as you've seen with some of the features I highlight, we've been investing hard to bring cutting-edge features such as graphical experience for non-professional data scientists, open source SDK for any framework, automated machine learning, and a few other things that I mentioned in that. So those ones I think they are very differentiated to what has been done probably the last 5 years in the market. So I think you have the option to choose both, and I have customers using both, which I think is also a sweet spot.
So thank you for a great presentation.
Thank you.
Yeah, I've never used any automated ML tools, but I'm curious, how do you handle hyperparameter tuning for these kind of automated tools?
Yeah, so I didn't go too much into detail. There's 3 ways you can use AutoML, the one you've seen. Sorry, I cannot see you, but hopefully you can hear me. The first one is the basic one you've seen, is a graphical one. So it allows you to choose a few things, not more. You don't go to a lot of detail into the hyperparameters. It's just really to get started. The second way to consume it, which of course is the one I prefer, is using the SDK. So in that case, you are coding a little bit, so you're specifying a lot more parameters to a function, which might be the definition of how you want to play with hyperparameters. And the third way is basically on Power BI, which is even more business user oriented, which you just basically tell what you want to predict and what are the variables, and it does everything for you. So you have the 3 ways, from very basic and to sophisticated, meaning into code level, but still automate what happens behind the scene.
Thank you for speech. Have you tested the AutoML, for example, in Kaggle competitions to achieve what the accuracy of your AutoML models? And yes,
If I have to test myself?
no, Microsoft AutoML engine.
It's a great question. I don't know. I'm sure people have tried it. It's actually just been out for a few months. I wanted to show something cutting edge, but it can for sure be tested for Kaggle. Probably some people.
It is interesting to compare with the Kaggle's other results and to what is the accuracy of the.
Completely. I think it's a great idea. I'm sure the next few months you'll see some blog posts of people doing that.